Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, hope you are doing well. Today we are gonna solve this specimen paper of IGCSE physics, code number 0625. Okay, so I must advise you to read the instructions and information carefully before you start the paper and follow them. All right, so let us start with question number 1 of MCQ paper 2. All right, a length of a string is measured between 2 points on a ruler. So you can see that it is starting from 2.4 and ending at 15.6. So the total length of the string, which is taking around a pen, is 15.6 minus 2.4. 2.4 is equal to 13.2. When the length of the string is wound closely around a pen, it goes around 6 times. So what is the distance once around the pen? So because the total length of the string would be divided by number of turns. So the answer is 2.2. all right, so A is the correct answer. Moving on to the next question. When does an object falling vertically through the air reach a terminal velocity? As you know that when an object falls freely, so it reaches to terminal velocity, and when terminal velocity means constant velocity, at constant velocity acceleration is always 0. So let us go through the options. When the acceleration of the object becomes negative, so acceleration is not 0, it is a negative, it is having a negative value. So okay, for B, when the acceleration of the object is equal to g, which is equal to 9.8 meter per second square, so again it is not equal to 0. So when the air resistance equals the weight of the object, all right, so it's the correct it looks like correct answer, because weight acts downward and the air resistance acts upward. When the two opposite forces, they become equal, so acceleration becomes 0 and object will fall freely with a terminal velocity. So answer is C. Moving on to the next questions. An athlete runs a 100-meter race in a straight line. The table shows how his speed changes with time for the first 5 seconds of the race. So the first row is showing the speed at different time intervals: 0, 1, first second, second second, third second, fourth second, fifth second, right? So what is the average acceleration of the athlete between 2 seconds and time 3 seconds? So this is being asked between this duration. So the duration is, the change in time is equal to 1 second, and the change in speed is equal to 5.7 minus 4.1. 0.7 minus 4.1, which is 1.6. So as acceleration is equal to change in speed divided by the time taken for this change. Okay, so 1.6 over 1 will be 1.6 meter per second square. Number 4, the gravitational field strength on the moon is 1.6 Newton per kg. An astronaut has a mass of 75 kilograms. So this is the mass and this is the gravitational field strength on the moon. So what is the weight of the astronaut on the moon? As we know that weight is the product of mass and the gravitational field strength. So mass is 75 multiplied by 1.6. So the weight of the astronaut on the moon will be 120 Newton. So the answer is C. Right? Moving on to the next question. Two objects P and Q are placed in a beaker containing a liquid. So object P floats in the liquid and object Q sinks. So the density of P, which is floating, must be less than the liquid. So density of P should be the less than the liquid, and as Q is sinking, so the density of Q must be greater than the liquid. So look at the values. We look at the options A, B, C, D. So it looks the density of liquid is 13.6 and the density of Q is greater than the density of liquid, and density of P, which is lesser than the density of the liquid, which obviously floats and it will sink. So the answer is D. Question number 6, a ball of mass 0.12 kilogram is hit by a tennis player. The velocity of the ball changes from 0 meter per second to 5 meter per second in 0.60 seconds. All right. So what is the average resultant force acting on the ball while it is being hit? So it's very easy. The change in velocity is 5 minus 0. Okay, so 5 minus 0 is obviously 5 meter per second is the velocity, and mass is 0.12 kg, and the time taken is 0.60 second. And we are going to find out the force, right? So it's how can we calculate? F is equal to ma, and mass is basically 0.12 multiplied by acceleration is change in velocity per unit time, 5 divided by 0.6. So if you calculate, it becomes 1 Newton. So the answer is A. Moving on, question number 7. A balloon and a mass are attached to a rod that is pivoted at a fixed point P, right? So the balloon is filled with helium, which is a gas that is less dense than air. The balloon filled with helium applies an upward force on the rod. The rod is horizontal and in equilibrium. So it means the turning effect or moment of balloon is equal to the moment of mass. So we can say that moment of balloon is equal to the moment of mass, right? Which action causes the rod to rotate clockwise? It means the moment of balloon is going to be greater than the moment of mass, right? So just assume the value of force exerted by balloon is 10 Newton, so its moment becomes 10 into 30, means 300 Newton centimeter. Right, so as it was in equilibrium, so its value will be 15 Newton, force exerted by mass. So 15 into 20, again 300 Newton centimeter. But when it is being asked that when action causes the rod to rotate clockwise, so it means the moment of balloon should be greater. So it should no more equal, but it should be greater now. So the value of moment of balloon should be greater than the moment of mass. All right, so let us go through the options. As we assumed the value is 10 Newton, so 10 into 40, 400 Newton centimeter is the moment in A option of the balloon, and 15 into 30 is 450 Newton centimeter. So moment of balloon is smaller. Okay, so this can never be our answer. Moving the balloon to 20, so 20 into 10 is 200. 20 into 10 is 200 Newton centimeter for the balloon, whereas 10 into 15 is 150 Newton centimeter. So here the moment of balloon is greater than the moment of mass, so it should be our answer. So as the moment of balloon is greater, so the rod would rotate clockwise. Okay, moving on to the next question. A hole is made in a square tile of a uniform thickness. Right, the diagram shows the tile hanging loosely on a nail. Where is the center of gravity of a tile? You know that center of gravity of a tile of uniform object. So just make it half by drawing a straight line of joining A to C, and a vertical line from the hole, a horizontal line from the hole. Okay, so where these two lines will be intersecting, the center, here lies the center of gravity, which is D. An object of mass 0.16 kilogram is moving forward at a speed of 0.5 meter per second. So that is this seems to be the initial speed, so we will assign by U. A second object, when we are talking about second object, so the mass of first object will be m1 and its velocity, initial velocity, will be u1. A second object, the mass of the second object is 0.10, so it is m2 is at rest. So the initial velocity of the second object is obviously 0. So the first object strikes the second object. After the collision, the second object moves forward at a speed of second object moves forward at a speed of, so this is the speed of second object after collision. So after collision, as speed changes, so we will write the final speed as v2 of the second object. What is the speed of the first object after the collision? All right, so it is very easy, because here is the law of conservation of momentum is applied for the system containing two objects. So as you know that total momentum of the system before collision, momentum before collision should be equal to the momentum after collision. Total momentum of the system we are talking about after collision, right? So m1 v u1 plus m2 u2 is the momentum of the system before collision, and m1 v1 plus m2 v2, right? And we have to find out the speed, which is v1, the speed of the first object after collision, right? So we have to find out v1. So m1 u1 is 0.16 multiplied by 0.5 plus, it will be 0 because the object is at rest, so momentum will also become 0 before the collision of second object. m1 v1, so the mass is 0.16, and v1 we have to find out, and plus m2 0.1 and multiplied by the 0.5, right? So when you calculate, so v1 it will become 0.1875 meter per second. So your answer is B. All right. A ball is at rest at the top of hill. The ball rolls down the hill. At the bottom of the hill, the ball hits the wall and stops. Which energy changes occur? So when the ball is at the top of the hill, so it has gravitational potential energies. So your answer would be either from A or B, gravitational potential energy, right? So when it starts moving or rolling down, so it is moving, so the energy due to motion is kinetic energy, and when it stops, so it will have internal energy. So our answer will be B. A man climbs a ladder. Which quantities can be used to calculate the useful power of the man, right? So it's an easy question. We know that power is equal to work done divided by the time taken for the work done, right? So the weight of the man and the time taken only, no. The weight of the man and the vertical distance moved only, no. So the work done by the man and the time taken only. So this should be our answer, because power is defined as the work done per unit time. Moving on, question number 12. A student uses her thumb to push a drawing pin thumb tack into a notice board. The pin goes into the board but does not penetrate her thumb. Which statement explains this? So if you will be going through the statements, you would find this statement: the pressure of the pin on the notice board is greater than the pressure of the pin on her thumb. That is why it does not penetrate her thumb. Okay, moving on, question number 13. A submarine is a boat that can travel below the surface of the sea. A submarine is 20 meter below, so this is height of the submarine from the surface of the sea. The pressure due to the seawater at this depth is P. On another day, the submarine is 26 meter, so the height is changed now, and on another day below the surface of fresh water. The density of seawater is 1.3 times the density of fresh water. What is the pressure due to the fresh water at the depth of 26 meter? So you can say that you have to compare when it was at the depth of 20 meter, right, and 26 meters. Okay, So as you know that raw GH density, raw GH, right? Raw means density and G means the value of G, which is 10 Newton per kg or meter per second square, and 26, right, at the depth of fresh water. And then and the density of seawater is 1.3 times, so we will write 1.3 raw. Okay, 1.3 times of the density of fresh water multiplied by G, 10, and the height in that case is 20 meter. So if we calculate, so we will find the value is 1, so it is equal to 1 pressure, or the same pressure. All right. Question number 14. When particles of a gas collide with the wall of container, the wall experiences a pressure. So what is the cause of this pressure? As you know that pressure is a force per unit area, all right? So as force increases, pressure should also increase. So why it is force is increasing? Because force is the change in momentum per unit time, all right? So particles, they are colliding, and after collision obviously they change their speed, and as the speed of particles changes, their momentum also changes, and ultimately or resulting in the increase in force. When force increases, so also pressure, or it has a direct effect on pressure, so pressure also increases. So our answer should be B, the change in momentum of the particles, right? So this is how we have completed our unit 1. Okay, so in the next video I will be solving next 26 questions according to the units mentioned in our IGCSE syllabus. So till the next video, take care. Allah Hafiz.